Hello everyone, welcome back to TechCloud. Today we are going to cover another interesting protocol. Okay, so one question. Have you ever wondered how your devices synchronize time across the globe, ensuring accurate time, right? So welcome to our video on network time protocol, the backbone of time synchronization in computer network. So this NTP network time protocol is a protocol that helps the computer clock time to be synchronized in a network. So whatever devices we use like computer, mobile, laptop or any other thing which require a timestamp that will use a NTP server or that will use a NTP protocol to sync the time according to the current time zone. So further moving, let's look into a little bit about the NTP version. NTP was developed by David Mills in 1981 at the University of Delaware, and the first version of NTP is NTP version 1, and this is the initial version of NTP was documented in 1985. It had limited functionality and security feature compared to later versions. Then it evaluated and came to the NTP version 2. It was published in 1988, and the NTP version 2 was aimed to improve the protocol's accuracy and introduced more capabilities. However, it still lacked comprehensive security measures. Then NTP version 3 got introduced in 1992 and documented in RFC 1305. NTP version 3 introduced significant improvement in terms of accuracy, robustness, and security. It incorporated cryptographic authentication to verify time source and enhance reliability. Later and the latest, we have NTP version 4. The most widely used version, NTP version 4 was introduced in 2010 and documented in RFC 5905. It includes many enhancements over previous versions, focusing on better accuracy, security, and support of modern networks. NTP version 4 offers more advanced algorithm, cryptographic features, and improved handling of timekeeping errors. So that's how the NTP developed, and we are now using NTP version 4. Now, moving on. So let's look into a little bit about the feature of NTP, which is the main feature we can say. So NTP server have access to highly precise atomic clock and GPU clock. It uses a coordinated universal time, which we call UTC, to synchronize GPU clock time. It avoid even having a fraction of vulnerability in information exchange communication. Also, it provide consistent timekeeping for file servers. So that's the main features of NTP and more. Moving on, let's look into a little bit about the NTP architecture. So degrees of separation from the UTC source are defined as strata. The various strata include the following, like we have stratum 0, which a reference clock receives true time from a dedicated transmitter or satellite navigation system. It is categorized as stratum 0. Then we have stratum 1. In this stratum 1, a device is directly linked to the reference clock. In stratum 2, a device receives its time from a stratum 1 computer. Okay, then the stratum 3. So in stratum 3, a device receives its time from a stratum 2 computers. So the stratum ranking continues from there and accuracy is reduced with each additional degree of the separation. Over here you can see on the screen that we have the three layer of the stratum 1, 2 and 3, and then all and whoever is consuming synchronization from a stratum 1 and stratum 2 will have a little bit of the accuracy problem. Okay, now moving on, let's look into a little bit about how does NTP work. So here on the screen, we can see that the NTP client initiated time request exchange with the NTP server. Okay, and then the client is then able to calculate the link delay and its local offset and adjust its local clock to match the clock at the server's computer. As a rule, we can say there is a 6 exchange over a period of about 5 to 10 minutes are required to initially set the clock. And once the clock is synchronized. The client updates the clock about once every 10 minutes, usually requiring only single message exchange in addition to client server synchronization. This transaction occurs via UDP, user datagram protocol, over port 123, and this NTP also support broadcast synchronization of peer computers clock. Then moving on, we have a WIA capture in which you can see that under the NTP protocol, we have the same information, the reference timestamp, the time, date and origin we can see, when it was received, when it was transmitted, everything we can see over here in the WIA capture. Okay, so moving on now, let's look into a little bit about the advantage and disadvantage of NTP. As the advantage, NTP provide internet synchronization between the devices. It also provide enhanced security within the premises, and it is used in the authentication system like Kerberos. It also provide network acceleration, which helps in troubleshooting problems. It used in file system; those are difficult in network synchronization. The disadvantages of NTP are like when the server are down, the sync time is affected across the running communication. Servers are prone to error due to various time zone and conflict may occur also. It has the minimal reduction of time accuracy, and when NTP packet are increased, synchronization is conflicted. Manipulation can be done in synchronization also too. So this is the advantage of NTP, and this is all about the fundamental explanation of NTP today, that how it works, what is the NTP architecture of NTP and so on. I hope this information is helpful for you. Please do like, share, subscribe to the channel, comment your suggestion and query, and don't forget to press the bell icon. Thank you for watching. See you in the next video.